Hello, good evening, everybody. Well, good day by the time you see this. Today we're going to look at graphing sinusoidal applications, so problems where they are modeled by a sinusoidal function. They happen all the time in the world. This first one's going to be a little contrived, but it's kind of fun. It's going to be about my moods throughout the day, and this is my little daughter Penny back when she was a little girl. What we're going to do when we look at these problems, we're going to kind of sketch the graph a little bit, and we're also going to try to think about what the a, b, h, and k values are for the functions. I always like to use cosine because it's easier to find max and mins for these. You could technically use any of them, but the goal is to create the equation from the graph and the given information. Alright, so I have a mood that varies sinusoidally throughout the day. I rate myself from 1 to 10 because who doesn't? Happiest, 10 being the happiest, 1 being the lowest. At 7 a.m. I'm at a 3, and at 7 p.m. I'm at a 10, and those are the min and the maximum values. So we're going to start the problem by kind of sketching a general graph for this. So the time in hours is going to be on the bottom here. And then along the side here is going to be my mood rating. And let's see what we have here. So 3 and 10 are my min and max mood ratings. So I'll just go by 2s. And 7 a.m. is the min, 7 p.m. is the max. That's, roughly a day. I'm going to go by 6s along the x-axis. All right, now for some points. At 7 a.m., I'm at a 3. So 7 a.m. would be 7 hours after midnight, because hours after midnight. I'm at a 3, so there's a point right about here. And then at 7 p.m., I'm at a high of 10. 7 p.m. is 7 hours after noon, so that's 19 hours total. 19, I am loving life at that point. So 19, 10, and 7, 3. All right, so let's think about a couple things in this problem. Now we want to get the a, b, h, and k values that are up there. So we can find out the next minimum value. If it took 12 to get from 7 to 19, it would take another 12 to get back to the minimum again. So 19 plus 12 is 31. So I'm going to have another point at 31, 3. At this point, I'm just going to do a sketch of my sinusoidal function so I can kind of get a sense of what this looks like. I graph at least one period, and it looks something like this. The midline now. So if we're at a min of 3 and a max of 10, that's a distance of 7. If we go 3.5 above the min, so 6.5, that'll be the midline of this sinusoid. This can also be used to help us get the amplitude. The distance from the midline to the maximum is 3.5. So let's take a moment now and write down what we know so far. The k value is going to be the midline of 6.5. The a value is the amplitude of 3.5. I'm going to use this as my start point down here, the 7, 3, because that was the first value given. And because I'm using it as my start point, it's going to be a negative cosine function, and also the horizontal shift is going to be 7. So I have the k value, the h value, the a value, the cosine. I just need the b value now. So it looks like from minimum to minimum took 24 hours, and that makes sense. We're talking about a day cycle here. So the period here is 24. If the period is 24, the b value would be 2 pi divided by 24, so pi over 12. Putting this all together, we have y equals negative 3.5 cosine pi over 12, just leave it in that form, x minus 7 plus 6.5. If you had done this as your start point, this would have been 19, and this would have been positive cosine. You could try to figure out what this point is and use positive sign, this point is and do negative sign. I always think it's just easier to use the first point that's a min or max on the graph. All right, now for the graphing part. as we put this in the calculator, make sure that your calculator is in radian mode. Go to mode, make sure it's radian. Since we did 2 pi divided by b, we're doing radians. The y equals, I put the equation in there. And the window I chose here, I just kind of looked at this and said, okay, what looks like a good window? And then I looked up here, what's a good y kind of min and max, and I came up with this. And if I hit graph now, that's what it looks like, which is pretty similar to the graph I have here, if I were to extend it that way a little bit. Okay, now for the follow-up questions, we have, what is Mr. Brown's rating right now? Well, I had to wait until my kids went to bed to make this video, so it is actually 9:30 right now. 9:30 is 9.5 hours after noon, so that is time x equals 21.5. This part's pretty simple. I just go to second calc, go to value, enter 21.5, and I get 9.28 as my rating. Now this next question is going to be a little bit more challenging. How many hours during the day am I above a certain number? So above 9 in this case. So I'm looking for up here, like where I'm really happy. The way to do this when you're given y values is to go back into y equals and actually put y equals 9 into y2. And what I'm going to do is find the intersection of that horizontal line and the sinusoid. So move the cursor over here, hit enter 3 times now, y'all, and we get 16.04 for 9. Technically right now I could just figure out how far 16.4 is from 9 and then add that to get the next one, but let's just do it again. So second calc, intersection again. This time I'm going to find the one to the right. Get the cursor close, hit enter 3 times, and we get 21.96, comma 9. To find out how many hours I'm above this, I would just subtract these two values. $5.92 hours. If I wanted to know the percent of the day that I was at this rating, I would just divide that by 24, which is the period in this problem. All right, so that is a problem where I'm given a min and a maximum point. Now we're going to look at one problem called circular motion, where it's more about a circle turning and what the equation of the sinusoid is based on that. So, a water wheel problem, if you can imagine this, it's a wheel that kind of goes through the water, picks up the water, and brings it up. And the diameter is 15 of this wheel, dips 5 feet below at its lowest point. So it's actually going to go underwater here. 1 full revolution every 2 minutes. That sounds important. A frisbee gets stuck in the wheel. The frisbee reaches the top of the wheel at 45. That sounds like a start point. Okay, so let's graph what we know so far. We know that the graph will have negative values, so I'm going to make this more like a XY axis than just the first quadrant here. It goes 5 feet below water, so I'll put -5 here. If it has a diameter of 15 feet, that means the highest it's going to go is 10. So 10 is about here proportionally, so I'll put a mark there for 10. My x-axis scale, if it makes 1 revolution every 2 minutes. Well, let's take a look at that in a little more detail now. 1 revolution every 2 minutes means the period is going to be 120 seconds. Because a 1 revolution is the period. It's how long it takes to get from one point and then back again when it makes a full revolution. My b value, therefore, is going to be 2 pi over 120, so pi over 60. And my scale is going to be 120 over 4, which is 30. So that means I'm going to scale this by 30 along the x-axis. Let's go a little bit further out here. All right, and this is going to be time in seconds. And this is frisbee height. Okay, so some things are set up here. Now let's take a look at this initial value that I mentioned before, the 45 seconds, it's at the top. So 45 is halfway between 30 and 60, and it's at the highest value of 10. Now, if it makes one revolution every 120 seconds, if it's at a maximum at 45, the next maximum will occur 120 seconds after 45 at 165. So I'm going to put this right here, 165, 10, and 45, 10 here. Because of the symmetry of these sinusoidal curves, we know that the minimum has to be exactly halfway between here, or half of a period. So 60 seconds later is at 105 seconds. So right here, we could also plot the points over here. Let's get the midline value. If this is -5 and that's 10, 15, 7.5 above is 2.5. So 2.5 is my midline here. So I'm going to have a point here, 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 another minimum here. And the sinusoid is going to look like this. And that's my graph. So now let's get to the actual equation. So far I've only discussed the b value. So other things, the k value is going to be 2.5 because that's the midline. My amplitude is going to be the distance here, 7.5. It turns out it's always just the radius for the a value, the amplitude. The horizontal shifts. Let's choose this as the start point because that was the one given. If that's the start point, it's going to be a positive cosine because it starts at a maximum. And we also know that the horizontal shift is going to be 45. All right, do we have everything? We have the b value from before, the k, the a, and yeah, we're good to go. So y equals positive 7.5 cosine pi over 60, the b value that I solved for earlier, x minus 45. Close that parenthesis up and add the midline of 2.5, and there is the equation. From here you could solve these other problems similar to how we did before, and angular velocity and everything. Anyway, hope this helped you out, and good luck with the rest of them.